Okay, we've all had lunch, we're nice and sleepy. I hope I'll keep you awake with a little story. My name's Rob Fitzpatrick, I work for White Star Software. I work on Protop along with Tom Bascom. That's about all I'm going to say about me and us, because I want to dive into the presentation, if my pointer will work. That's unfortunate. Bear with me a moment. Okay, no pointer. Things are going well. Yeah. Okay, technical issues resolved, I think. Let's just dive right in. I'm going to talk about a feature called OpenEdge Diagnostic Data Collection, which is a long name, so I'm just going to say DDC from now on. We're going to talk about why this feature exists in the first place, how it works. Then we'll dive into a case study from one of our customer sites and the lessons that we've learned from that. We'll talk about a couple of undocumented features, and then I'll wrap up. So, why do we have this feature in the first place? Well, this might resonate with one or two of you. The life of a DBA is hopefully boring, but occasionally not. Some days you have lots of excitement, which means bad stuff is happening. Here are some examples of some bad stuff that you might see in your database log, like system errors. I've seen most of these. Not all of them, though, thankfully. Or BI threshold reached. That's not good, although hopefully yours is larger than 30 megabytes. Pop quiz, what causes BI growth? Long transaction running, what kind of transaction? Active. That's one. If you have a long-running active transaction that's not doing anything, will that cause BI growth?
That transaction. But the others will.
But the others will. So if there's activity, BI writes, along with a long-running transaction, that's when you get BI growth, right? Because the cluster that contains the notes for that long-running transaction can't be reused. So eventually, more clusters have to be added, and that's logical BI growth. You didn't know there was audience participation in this, did you?
It's right after lunch.
Okay, how about this one? That looks familiar. And remember that the user who sees a lock table overflow, or LTO error message, isn't necessarily the perpetrator, the bad guy who caused it. More on that later from our case study. So, more audience participation. Has anyone seen these errors before in their logs? Okay. Is there anyone who's never seen these errors before? Welcome to OpenEdge. Buckle up. Okay, so here's a hypothetical scenario, although I've been through it. One of these errors happens in your in your database or maybe at your customer site. And then sometime later, somebody notices the error. Maybe it's the next day or the next week, next month. And in the meantime, the state has changed in the server. Maybe they've restarted the database or rebooted the whole server, replaced the server. And then they come to you and they ask, why did this happen? Why did we have this lock table overflow? And you reply, I can't tell you. Because it's too late. There was all kinds of really valuable diagnostic state that existed in that database at the time of the error. But now, the VSTs have been emptied, or the users have disconnected, or the file system has changed, or the OS process list has changed. Nothing is the same as it was at that time. But it's not even necessarily a case of you were too late or you didn't see it quickly enough, because even if you're vigilant, even if you're watching the VSTs and the logs in your monitoring software like a hawk, you can't be quick enough to type all the commands you'd like to type and get all the data you'd like to get right at that moment. If you have a standard lock table of 8192, an overflow can happen like that. You just can't be fast enough. So wouldn't it be great if the database could be vigilant on your behalf and watch for these events and capture data about them as they happen? Guess what? It can. So this is diagnostic data collection. If you're not familiar with it or you haven't used it, it was introduced in 11.7.1, about 6 years ago now, and it's pretty well documented. And we're going to dive into how it works. So in a nutshell, DDC is a configurable framework for automatically capturing data about database events. And I'll define what events means in this context. They are the ones I've talked about earlier: lock table overflow, BI threshold reached, and system error. And we've got a bunch of startup parameters that we can use with this feature that determine how it works, although we don't have to enable it with startup parameters. We can do it online as well, and I'll get into that in a bit. So our options are, as I said, we can use these parameters to configure the feature, or we can also do it online in Promon. In Promon or programmatically. So you can, as long as your 11.7 database has the _db params VST, and it should, you can use that to enable this feature programmatically. You get data that's dumped from VSTs that's written to output files, to flat files. Those can either be in CSV format or JSON. And there's a logging level that you specify for each of the 3 event types. And you can set a separate level for each type of event. So the level that you set will determine whether you get summary logging, which is data from some of the VSTs, or detailed logging, which is summary plus a bunch more VSTs. And which ones those are, again, varies by event type. You can also, in some cases, generate ProTrace files for self-service clients in particular. That's Unix only, though. And that can be very useful if you're not familiar with ProTrace files. They contain the ABL stack trace of a client at a snapshot in time, which can be very useful for diagnosing, what was the bad code that they were running. So here's a breakdown of the 3 event types and the VSTs that the data comes from at the summary level and at the detailed level. So with lock table overflow, you get the user lock, which is going to be 1 record per user with their lock counts. At the detailed level, you get a dump of the entire lock table. So if you had a lock table overflow and your big L is 500,000, that's a 500,000 line CSV file or a very large JSON file. And you also get a dump of the transaction table. For BI threshold reached, we have a bunch of VSTs with information about the transaction subsystem. And with system error, there's just really one level of detail. It's the summary level, and you get the user log table again for that. Because system error is kind of generic. You can have it for a lot of different reasons. Some more options that we have here. You can choose to capture every single instance of a particular event, or only those ones that were fatal to the database, the ones that involved a shutdown. I haven't found that particularly useful, but you might. You can also choose to capture the data for all 3 event types when any one of the 3 fires. Again, I haven't done that, but you might. A powerful feature is that you can create a script with a particular name and have the database run that script at the time of the event. So, you can let your imagination run wild here. You could capture data from other VSTs that are interesting to you. You could capture information about the process list, the file system, how full your disks are. You could capture, information from your application about which batch job is running or which order you're picking or whatever it might be that's appropriate for you. So that's a very powerful extensibility feature. You can choose where the data is written. So this is called the diagdir. That's one of the startup parameters, and you specify a path. If you have a federated application, so you've got multiple databases, you don't have to have a separate diagnostic directory for every single database so that you've got multiple places to go and look for the data. When the data is written into the CSV files, one of the attributes in the file is the database name and path. So you could just specify one diagdir across all of your databases, and then you just have one place to look for your data. So that's convenient. Within that diagnostic directory, each event that happens gets its own subdirectory, and then within that, that's where the output files are written. We've got this very long name for the directory here. So it's got a prefix, which by default is diag event, and then you've got a date and timestamp, and then the event type, and a counter. So if you have 5 lock table overflows, there'll be 1, 2, 3, 4, 5. You might even have more. And then also in the diagnostic directory is sort of a master tracking file. And this will be in the same format that you chose for the output files, either CSV or JSON. And that's called diag event underscore tracking, or if you change the prefix, it'll be something else tracking. And within that are 2 line items, at least in the CSV format, that mark the start of the event and the end of the event. And so if you were building some scripted monitoring of this, that would be the one place you would look. You could parse that file, see have there been any new events today or any new events since the last event I know about, and so forth. That's the purpose of that. And this is, sorry, a little bit of an eye chart, but this is what the tracking file looks like if we bring it into Excel. So you can see the attributes here. So we've got a date and timestamp, the PID and thread ID of the process, the event level that was specified, what type of process was it, what was the event that triggered it, and then database name and the event data directory, and then start and end. You'll notice here there's one that I didn't talk about, which says DB status. So we've got a lock table overflow, a system error, a BI threshold reached. There's this other one, DB status, and I'll talk about that in a little bit. For CSV, if you choose that format, the default field separator or delimiter is a space. You can change that with the diagfs parameter. I don't do that myself because the space is, it works well if you're importing this data into ABL or you're bringing it into Excel. That'll work fine. There's a diagpause parameter, and what that says is you specify a value, a number, and when the event fires, the activity in the database will be paused for that number of seconds. And so the idea behind this is that resources are held by those users during that pause, and you can get a more complete or more what's the word I'm looking for? More consistent. Thank you, Tom. You read my mind. More consistent snapshot of the data than if activity had been continuing. You could get into trouble though if you pause for too long. So be careful with this in an OLTP environment. And if you set a pause and you decide you don't want to wait that long because you don't know, for example, how long your custom script is going to take to gather all its data, you can terminate the pause early by creating a file with the special name diag_completed in the event subdirectory. And then that will cause an early termination of the pause. So I talked a little bit about this extensibility mechanism, this diagnostic procedure. It has a special name. It's called diagproc. That's its name in Unix. In Windows, it would be diagproc.exe or diagproc.bat. If the exe exists, it'll be run. If it doesn't exist, it'll look for the .bat and run that if it exists. This file is something you would create. It has to be in the database directory. And if it exists and if you specify an event level that causes the diagnostic procedure to be run, or diagnostic process, I guess it is, then it will run that. You can also give your script or batch file input parameters. So it will be passed 3 parameters, which are the name of the event directory for this event, the event type, and the database name. So what that allows you to do is you could have, let's say, custom code blocks within your data gathering script that say, you know, if it's my accounting database, do that, or if it's my marketing database, do this. Or you could say, if it's a lock table overflow, gather this data, but if it's a BI threshold reach, then gather this other data. So you can further customize your data gathering based on your needs. You don't have to wait for an event to actually happen in order to capture the data as you've configured the capture to work. So you can do an ad hoc capture. There are a couple of ways to do this. You can do it programmatically by setting a value in a VST, or you can do it from within Promon, which we'll see in a moment. So whatever data capture you've specified with your event levels, that will determine what goes into those files and which files get created. And if we remember what the tracking file looked like, I pointed out that there was one event there that said DB status. That's an indication that it was an ad hoc capture. So if you're going to do this via the ABL, you would change this field in the DB status VST. It's called DB status initiate diag. Set it to yes or true. This is not production quality code. Please put in error handling. Because there is a bug in certain releases of OpenEdge where the DB status record doesn't exist. When you do this, data is captured for all of the event types, and the event type name, as I said, is DB status. So there's an example of what the event directory name might look like if it was an ad hoc capture. So there's a whole screen in Promon dedicated to DDC, and as we see the option at the bottom, option 9, this is Promon R&D 414, it says collect enabled diagnostic data now. You can also see in this screen that the event levels, which I'm going to go into in a little bit, are summarized here helpfully. So it's sort of a decoder ring for the event levels, which can be a little bit confusing. And it also displays the values of those startup parameters that I talked about. But this isn't just a display. You can also select those items and make changes in this screen as well. So it's a data entry screen as well. And now my pointer works again. Okay. All right, so when you specify the startup parameters, one of them is diag event, and that takes as its parameter a comma-separated string of event type, colon, and event level. And there are 15 levels that are shown here. Well, really 16. 0 means don't collect data for that event type. And so based on the number that's specified, you're either going to collect no VST data or just the summary, whatever that happens to be for this event type, or summary and detail. For each of those combinations, we have the possibility of generating or not generating ProTrace files, so that would be levels 3, 7, 11, and 15. Again, ProTraces are only Unix and only for self-service clients. There's the diagnostic process that I talked about earlier. So for each of those combinations, you can either execute a process if it exists or don't. And then, as I said, there's the option of reporting data for all 3 events when any one of the 3 events fires. So that's levels 8 through 15. And if you add a negative sign to the value, so that would be levels -1 through -15, that means do whatever is specified on that line, but only if the event was fatal to the database. So for example, if it's a lock table overflow, generally that doesn't shut the database down unless there isn't sufficient excess shared memory to extend the lock table, in which case it is fatal. So a couple of things to note here that are, in my opinion, a little unfortunate with the design is that whenever we collect detailed data, we have to collect summary as well. You can't just do one or the other individually. Detail always means and also summary. And also, you'll notice that when we generate ProTraces, that's only when we're collecting both summary and detailed data. And that matters in particular with the lock table overflow event type because for the LTO, detailed means dump the entire lock table. And we'll see the effect of that when you have big L of 1,000,000. You get some big files. So some suggestions for these various startup parameters that I talked about. For the diag dir, where all this data gets located, I suggest you put it, if possible, on a non-database disk. It should be a fast disk because you could wind up writing quite a lot of data in a short time. Because remember that events aren't necessarily interspersed in time. You might get a flurry of events in a short amount of time and be writing a lot of data. And depending on which event types you've specified and what type of event occurs, and some other things like the size of your lock table, there could be quite a variance in how much data is being written in those CSV or JSON files. So the diag event, again, that's where you specify the string of the 3 event levels. Again, be careful with a very large big L. You're going to get some very large files. Another tip that we learned the hard way is you may not want to generate pro traces for the system error event because sometimes they happen one at a time, but sometimes they don't. You might get 4 or 5 in a row within a fraction of a second, and every one of those is an event, and every one of them might have pro traces generated for every client, and every one of them is going to write some CSV data. So that can impact your system availability. There's another parameter I haven't really talked about yet because I don't think it's terribly useful. You can specify a single event level and have that apply to all 3 events. But if you specify both, then the diag event will override the diag event level. So it's just a little bit of shorthand in case you wanted, let's say, level 3 for all 3 events. It saves you a bit of typing, but that doesn't really justify a new parameter in my opinion. The field separator I've already talked about. That's if you have CSV format, you can specify something other than space, but I find space works well. Diag format, I used CSV because that's what my little DBA brain knows how to parse. If you like to work with JSON data, then go for it. The difference there is that while with CSV, you're going to get an individual flat file for each table that gets dumped. With the JSON, it's going to be integrated together. The diag pause we talked about, again, be careful with that. I haven't used it, so I don't have any field experience to talk about. But I could see where it could be problematic if you paused for a long time. Pardon me? The users will tell you if you specified it too long, yes. The prefix that we saw in the directory names, diag event underscore, that's just making your path that much longer. You might want a shorter prefix, or you might want something that's meaningful to you. Perhaps if it was, again, a federated environment, you might want your logical database name as the prefix. You don't have to, because you've got the database name in the file, but if you wanted just to be able to scan the directory and see, which one was the culprit this time, that might be helpful. The diagnostic process I've already talked about. In 12.2, it was made into a new parameter unto itself so that you can have your own name, which in theory is cool, but it doesn't actually do anything. So if you don't name it with the hard-coded name, it simply won't run. So just pretend that doesn't exist, at least until 12.8, where hopefully it's fixed. Most of the bugs that I've talked about have been reported to tech support, and I understand that there are fixes on the way. So here's a flowchart that I shamelessly stole from a progress presentation, but I couldn't do better, so I just borrowed it. And it describes sort of the workflow that happens under the covers when an event fires. So when an event happens, it's a lock table overflow, you hit the BI threshold, or it's a system error. The database looks to see, do we have DDC enabled? Is it enabled for this event type? It records a start entry in the tracking file. It creates the new subdirectory in the diagdir, and then it looks to see, did you enable the feature for generating pro traces? If that is true, then it sends the signal SIGUSER1 to every one of the clients. So be careful if you have lots and lots of shared memory clients on Unix. If you've said you want a diag proc, then it will execute that. And if you've used a pause, then it's going to be in a loop here until the pause expires one way or another. And then finally, it records the end entry in the tracking file, and that's the end of the event process. So again, here's our Promon screen, R&D 414. So if your database is up and running and you want to start using this feature, you don't have to restart your database. You can turn all of this online, all of it on online. You can change the values. So if you just type in the number, then it gives you a prompt to enter the new value. Be careful with the directory because if you type 1 and hit enter, it'll give you a space to enter a new directory. If you just hit enter, it'll replace this with a blank. So now you have no diagnostic data directory. What it'll do in that case, it'll still work, but it'll write the event subdirectory into the database directory, so you're going to get an accumulation of junk there. As a side note, if you specify diagdir and the directory doesn't exist, the database won't start, so make sure that you actually have that path. What else did I test? Oh, if it exists and then you delete the directory, then again, it'll still work, but it'll write the data. It'll fall back to using the database directory as the diagdir. And as I said, these event levels that I showed you the big table of, it can be, like, don't even bother trying to memorize them, at least I can't. So you can just type in the numbers until you see the result you want. Like you can type 6, 3, and it'll tell you, oh, lock table overflow at level 3 means you get these 3 things. You have to look up what those things are in terms of which VSTs are collected, but once you know that, then it does a handy translation of these things. The only thing it doesn't translate here, you can see I have a -15 instead of a 15. So that would be level 15, which is all of these things, but only if the event was fatal to the database. But I guess they didn't have room to put that on the Prolon screen, so they didn't. Okay, so Tom and I had an adventure at a client site. This was a client with some chronic application problems, lock table overflows, and you get a hint of that because their big L was $1 million. Well, is $1 million. This is an 11.7 customer on Red Hat. It's about 1.7 terabytes-ish, maybe a little larger. 1,800 users, all shared memory, and big L of $1 million. And this was the event level configuration that we chose. So we said -diag event, and then this is the syntax. So you say event type :level, event type :level, event type :level. If you leave out one of these 3 event types, it just won't collect for that event. So in this case, 3 means summary VST data, detailed VST data, and generate protrace files for shared memory clients. So we put this in and waited to see, what will happen. Will we get a lock table overflow eventually? Well, bingo, we got one the next day. I say one, but actually it was more than one. So here's a sampling of the event directories that were generated. This was on Linux, but this is a screenshot from my laptop. So you can see in here in the red box, this is the time portion of the date and timestamp. So we start at 12:11 and 1 second. By event 7, we're at 12:11 and 10 seconds. So they're happening pretty rapidly. But that's not all. Now we're down at log table overflow 114. Yeah, 4 minutes later. So, an exciting day. So, what happened here? How did we get so many lock table overflows in such a short span of time, especially with a huge lock table? Well, users are crafty and not always in the way you would like them to be. There was a purge job in this particular application where the user could choose a batch size for the deletes that would determine basically how large that transaction is in terms of how many records it's going to delete in one. And knowing that the lock table was set to 1 million, they set their batch size to 997,000. So the net effect of this is that for the other 1,799 users, they basically have a big L of 3,000, which is not a good combination. So the legitimate activity from their other well-tuned code that the other users were running was causing they only have this much lock table left, and it's just boom, 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 overflow after overflow, because those 1,800 users were using up the other 3,000 locks quite frequently. And if that were the end of the story, it might not be so bad, but we had a little more excitement. You can see here a whole lot of system error events, and also just another lock table overflow thrown in for good measure. So why did this happen? Why did a whole lot of this happen? We're down to event 247. Yeah. So these lock table overflow events, each of them were writing the summary CSV files, the detailed CSV files. They were signaling every user to generate a protrace for every event. And remember, there were 114 of them in 4 minutes, so that's a lot of signaling and a lot of protraces. And so these clients became unresponsive because they were spending all of their time doing this and not running the application. And so the customer decided, I have to intervene. I'm going to kill these guys because they're not doing anything useful anyway. However, they didn't just say kill, they said kill -8. And if you're not familiar with that, that's SIG-FPE in Linux, which is a floating point error. And guess what OpenEdge thinks of a floating point error? It's a system error. And so that caused all the DDC logging for the system errors. And here's a snapshot of what it would look like if you did a SIG-FPE on a client. That's what shows up in your database log. So, yeah, they had a fire and they threw a bunch of gasoline on it. Fortunately, however, there is a silver lining to this cloud. We actually got some really valuable diagnostic data out of all of this once the database got restarted, because that's the next thing they did after killing all the users. Still not working well, let's kill the database. Well, restart the database, they didn't kill it. And so what we found in our lock table summary CSV file was, well, a confusing looking jumble of data, but when you parse it, I wrote a little parser, it looks a little nicer, and it becomes pretty clear who the bad guy is. So we've got some summary data about the database and then the data from the line items in that CSV file. And here's our user with 997,266 locks. I think he's the one who did it. I've circled this blank because this is an integration of DDC and CSC. If you're not familiar with CSC, that's Client Statement Cache, and Tom has a presentation about it today at 3? Okay, so you should go to that, especially if you don't know what CSC is. So Client Statement Cache is an optional feature. It was added in 10.1c, and you can configure clients, ABL or SQL, to send to the database every time they access the database what they're doing right now. So for an ABL client, that means part of their call stack. It can either be the top frame of the call stack or the whole thing. I recommend you just use the top frame configuration because that's going to be less data coming across the wire. And in the case of a SQL client, it'll be the SQL statement that's executing. So it's a really, really powerful diagnostic tool, and that data gets cached in the user record in the _connect VST. So if that data exists, then theoretically, it's written into the CSV file generated by DDC. However, we didn't get any data in spite of enabling this feature. So that's a DDC bug, unfortunately. But it's been reported to tech support, so hopefully we'll get a fix on that in the next release. So overall, this was a success in terms of determining root cause. We were able to identify the program. We could, talk to the programmer and say, it's this line of code. We didn't get it from CSC, but we got it from the protrace file. We could tell them the client was running this program and they were on this line in that program, so they can look it up in a debug list of their code. And they were able to find that issue and fix the query. We've since then had other events where we identified different programs that were causing lock table overflows, and that's also been reported to the vendor to be fixed. So we've learned a few lessons along the way. Again, as I mentioned, if you have multiple databases, you don't have to have multiple diagders. You can just consolidate it all into one. It was designed with that intent because you get the database path within the CSV data. The lock table detail file is rather large if you have a big L. In our case, we had big L of 1,000,000, and that resulted in a 160 megabyte CSV file for every one of those 115 events that we had in the span of 5 minutes. So in your case, if you have a default big L or something close to that, don't even worry about it. It's going to be, measured in kilobytes. But if you have a super large, like a 7-digit big L, be aware that you could be writing a fair bit of data. Hopefully yours won't be as frequent as ours were, but it's something to be mindful of. You don't want to be filling your disk, or if you have very slow disks, that could just exacerbate your problems. For system errors, because it's kind of a catch-all error message and they can happen for many different reasons, and in particular they can happen in bunches. It's not uncommon to see 3 or 4 in a row in a database log that really have one root cause. Be careful with your logging level there. In particular, I would say be careful about using the protrace feature. If you're just writing a little bit of CSV data, it's not too bad. But in our case, where we had this storm of system errors followed by a storm of creating protrace files, it really impacted the clients. In terms of the lock table detail file, you don't necessarily get a lot of value out of that because it's giving you attributes of every single lock table record. So unless you really care about which table was it, which rec ID was it in that table, then the lock table summary, which tells you every user and their number of locks, that's what you care about, because you want to find out, okay, who's the user or top 2 or 3 users who are consuming all of the lock table, and then what code were they running. You don't really care about the guys who have 2 and 3 locks. That's normal. So that just says what I just said. However, if you want only the summary data, you don't get protraces, so that's a trade-off that you have to think about. Ideally, if we could use the combination of client statement cache and summary logging, then that would give us everything we need for diagnosing LTOs. But unfortunately, it's hit or miss. It's not that we got no CSC data, it's just that we got, 1 or 2% maybe of the users. We got their CSC data, and the rest of them, it was blank for some reason. So I don't know if that's a scalability issue, and maybe it works with a smaller database. That's just speculation. I have no idea why it doesn't work, but it doesn't work. So some of this I've already covered. This first one, it's very minor. It's a doc bug. If you look at the documentation for DDC, it will tell you what are the CSV files or JSON files that get generated for each of the VSTs that we collect data on. These 2 aren't in the docs, but you'll get them for the BI threshold event at detailed logging level. Another little minor annoyance is that you can see the date and timestamp in the directory names has millisecond precision, but the milliseconds are always .000. So it has millisecond precision, but only second accuracy. So that's been reported, and they're fixing it. Diagproc, as I mentioned, just doesn't work at all. So that's, again, just a minor inconvenience, because you can just use these hard-coded names work fine. So if you stick to those names, then your procedure will run if you've got that event level. Here's another one that we noticed quite recently. There was, same client, we had 4 events in quick succession. 1 was a system error, and 3 were lock table overflows. When we went into the LTO event subdirectories, they were empty. The files had been generated, but for some reason they went into the system error directory. So if you go into the event directory and you don't find the file you expect, hunt around a little bit. That's the best advice I can give you. And or do a file system search. Hopefully you'll find your file. If not, please report it to tech support. Again, when we were generating a very large number of pro traces, that caused those clients to become unresponsive, which caused the questionable decision to kill them in a way that caused system errors, which we were also logging, so that caused more, and it was just a cascading effect. So I guess the advice here is don't use kill -8 to to kill an ABL client. It's just not advisable. And again, the CSC bug that I mentioned, and I know it's a DDC bug because we confirmed that CSC was enabled and that the data was in the cache in the _connect record, and we could also see it in Protop, which also shows the CSC data. However, it just wasn't present in the CSV files, so there's something screwy going on there. One other little minor thing, it's not a functional bug, but it's something you may notice, is that in some of the CSV data, there's one of the columns is domain ID for a user. In this case, we can see user Rob, number 1, has domain -4. This is not a multi-tenant database or anything like that. There aren't any domains. That's just what you're going to see. This is from Promon, and that's the correct domain ID. Unfortunately, the data output routine seems to have handled -4 as an unsigned integer instead of a signed integer, and it's what's that, 18 quadrillion? I don't know. It's a big number. It's the wrong number. It's actually -4. But again, it's just a cosmetic issue unless for some reason you're parsing domain IDs. So, wrapping up, DDC in and of itself, it's not a complete end-to-end troubleshooting tool, right? What it's going to give you is a lot of data. You have to decide how much data you want. You have to decide what data you want for each event type. And you have to notice that the data is there and that an event has happened. And you have to analyze that data and make sense of it and figure it out. It's not difficult, but you don't get it for free either. You have to do a bit of work. If you're going to be doing this over and over again, as I indicated, you might want to have a little bit of tooling to be able to parse these CSV files or a workflow to bring them into Excel or a database or whatever for analysis so that you're not doing this manually every time. So, do I recommend this unreservedly? No. And that's not a statement about DDC. It's more a statement about the diversity of OpenEdge environments. Not every OpenEdge database is equally loved. There are lots of applications out there that run on a database server and no one's looking at it every day, and it runs and it runs and it runs. But you don't want to enable DDC in an environment like that. If you don't have people looking at the data, if you don't have people monitoring the file system or knowing that these files are piling up and they're an indication of a problem, you don't want it in that type of environment. Or if it's, an unspectacular DBA who isn't actually going to look at the data, then, if it's that type of environment, you don't want to, create the data if people aren't going to look at it. Or if you have a very diligent DBA who's going to report this stuff to development, but development says, yeah, I don't care, I'm too busy writing the new bad code. I've been there. Then again, you're just wasting your time in your disk space by generating these files. However, yes, there are a few rough edges, and in the course of our research and the planning for this talk, we've already found a bunch of them and got them reported to progress, and they're being fixed. And I believe some of the fixes are already on the way in 12.8. So it sounds like I'm saying a lot of bad stuff about CSC, about DDC, but I'm really not. It's an imperfect feature, but there's a lot of value in it. Here's an enhancement idea from Tom. This is from the Ideas portal, and he suggested having a cap on how many events we're going to have in a unit of time, which I think would be a very helpful feature. It would prevent that event storm phenomenon that we saw that the customer created. So if you happen to be on the Ideas portal and you see this, feel free to vote for it. We need the votes. Another thing where you could help is that when this feature was pitched to us in 11.7, it was described as a framework for capturing data about events. There's no rule that says it has to be this exact list of 3 events. There could be others. There might be other cases that you think of that would benefit from being a part of this framework. So again, if you think of those, post an idea in the Ideas portal, and a lot of things that get posted there make their way into the product, so it's not a wasted effort. So the bottom line is, the big question, should you use DDC? Yes, I believe you should. Given the caveats of what I've said before, if you're actually going to look at this data, if your developers are going to work with this data and take it seriously, then absolutely. There are some bugs. They're mostly inconvenient, and you can work around them. And understand that this test case that we talked about was from a database that was kind of exceptional outside the norm in a few ways, very large, lots of users, huge lock table. You won't necessarily even encounter some of these bugs. But when it comes to diagnosing problems, especially lock table overflow, where capturing data at the moment is so critical to finding the root cause, there really isn't a better way of doing it. So I think that's a really powerful reason for adopting it. Again, you don't even have to restart your database to try it out. And it's pretty easy to cause these events. So you can play with it in your test environment and see what it does. Take it for a test drive yourself. You don't have to go right to prod with it. And especially the diagnostic process is a really powerful mechanism where you can decide, hey, I don't like this list of VSTs that Progress chose for this event. You can extend it. You can collect data from whatever you want and do that with the with your own script or program. And that's it. Do we have any questions?
Just a small one to make sure, but are there any associated performance issues? So, leaving aside having the long pause or a lock table with millions, if you've got fairly normal data, are you going to see any kind of penalty if you're running this more in a monitoring kind of way? Or, you run it every so often just to see what happens?
No. So the question is, did we see any performance degradation or impacts from keeping this feature enabled? No. And because you don't know in advance when these events are going to happen, hopefully, you want to keep it enabled all the time, just so that you're not lamenting the fact that you see an event and now you have to go turn it on and wait for the next instance of that event to happen. But at this customer of ours, they're very sensitive to performance concerns, and they haven't reported any degradation. I mean, it's not something that the client side is aware of, and it's not slowing down the database engine. It's creating a little more work to be done when the event happens, because we're writing to the disk, and that's not free. It takes some cycles. But no, that hasn't been a concern. Okay. In the back. Sorry, can you speak up a bit, please? When you turn on the client statement cache? Yes. Do we define the output directory? No. However, in this case, CSC was configured for only the single stack frame. So it's a small amount of data, less than 255 bytes. So it fits within the the memory cache. It doesn't have to write out to disk. Anyone else? Mike.
How big was the directory with all those files that you
That was 13 gigabytes.
have asked in text?
Yes. 13. Well, one good thing is that this customer has exceptionally fast disks, as you would expect for a 2 terabyte database. So, you know, it was written quite quickly. Yeah, getting it onto my laptop took a little longer. Anyone else? Okay, well, thank you for attending. I hope you found this useful, and I hope you find DDC useful in your environments. I'm active on the community, so if you have any questions about it, feel free to post in the database forum. And I hope you enjoy the rest of the conference. Thank you very much.